Mr. Harris here, and welcome to a new video of chapter 9.3. In this video, we're going to talk about more examples of the word equation that we learned about neutralization, and I'll also introduce you a concept of conservation of mass. Alright, let's begin. In the previous video, I mentioned about the word equation. Acid and alkali, they are the reactants in the word equation. So when you react them together, you neutralize, and you would get a salt and water. These are the products. And the process is called neutralization. So let's see some examples of neutralization. For example, you have sodium hydroxide as the alkali, and you have hydrochloric acid as the acid. When you neutralize both of them together, you'll get a salt, which is sodium chloride, and water. So you might have heard of sodium chloride. This is the table salt. You may find it in your kitchen. This is what you add to your food, right? However, just to tell you, the salt that we're going to talk about from now on, it's not only going to be this salt, because there are many different types of salts. So to be more specific, you can tell your parents that whenever we talk about salt, please call it table salt or the kitchen salt, so it's easier for us to differentiate between the salts. Let me show you an example. You have the alkali, potassium hydroxide in this case, and when you react it with nitric acid, which is an acid, when you react this specific alkali with this specific acid, the salt that you get is potassium nitrate. This salt is, of course, different from the kitchen salt, which is sodium chloride, because, of course, it has totally different reactants that made the salt, right? So an example or a use for this type of salt is we use it in chemical fertilizers. Another example, you have an alkali sodium hydroxide, you react it with sulfuric acid, you get a specific type of salt, which in this case is sodium sulfate. Sodium sulfate is used as washing powder. So these, do you notice all different types of salts? They will have different uses. All right, but they follow the same word equation, acid plus an alkali. When you react them together to neutralize, they get a specific type of salt plus water. So you may ask me, Mr. Harris, how do I know the name of the salt that is formed? How do I know sodium sulfide is formed when I react these two reactants? How do I know this is potassium nitrate is formed when I react these two? Let me give you a general idea how it's formed. So we're going to follow the color, okay? Follow the color of my pen. Over here, you have sodium. The name of the sodium, the first name, it comes from the first name of the alkali over here. The second name of the salt, let me use pink, which is chloride. It comes from the first name of the acid. So, what do I mean? The first name, it comes from the alkali. Whereas the second name, it comes from the acid. Alright, this is just a general rule of thumb. It may not be entirely correct, but it gives you the general idea how we name salts. Okay? However, sometimes we might need to change the name. For example, chloride, sodium chloride, the word chloride is not exactly the same as chloric, but we get the general idea of how the name is formed. Alright, let's keep this in mind and try the same thing for potassium nitrate. Let me go ahead and rub this out first. So potassium, the word comes from the first word of the alkali. And nitrate, the word will come from the first word of an acid. Right? So potassium nitrate. Let's do the same thing. Can you figure out for this one by yourself first while I rub it out? You have sodium over here. It comes from the first name of the alkali. And then you have sulfate, which is the first name of the acid. Okay? So hopefully this helps you out. We'll do some questions related to this in the next video. So just to summarize so far, the type of salt being formed in neutralization depends on the types of acid and alkali they react. So the salts that are formed are not always the same. It would depend on their reactants. It would depend on the acid and alkali. Now let me introduce to you what is conservation of mass. So you may ask me, Mr. Harris, so when I react the acid and alkali, is there any difference between the mass in the beginning and the mass at the end of the reaction? Say for example, in the beginning I used 20 grams. Okay. How about at the end of the reaction? Will I have a loss in mass? Will the mass be, for example, 18 grams? Will it be more? Will it become 22 grams because there is salt formed? Or will it remain the same, 20 grams? What would it be? So that's what we're going to find out now. So we're going to find out whether, in this practical, we're going to find out whether there's any change in the mass in the process of neutralization. So how are we going to figure it out? First, we will get a beaker, and then we'll put it on the electronic balance. After we put the beaker on the electric balance, then we will set the balance to 0. So we will click a button and set it to 0. Afterwards, we'll get two test tubes. We'll get the acid and the alkali, so the reactants, and place them on the electronic balance inside the beaker. And I'll see what is the reading on the electronic balance. So over here, we can see that the reading is 11 grams. So let's see what is the total mass of the test tubes and the solutions. So the total mass, as we can see right over here, is 11 grams. Let me write that down. 11 grams. Afterwards, what we do is we're going to start the reaction. So you pour the acid into the alkali, or you can do vice versa. You can also pour the alkali into the acid, doesn't matter. Afterwards, you will shake gently, and obviously neutralization would occur. After 10 minutes, so you let the reaction occur. The question now is there any precipitate being formed? And the answer is yes, there are white precipitates. Precipitate is a word for small solids. So you would notice that there are some small solids being formed in the tube, test tube, because these small solids are actually salts. This is the salt being formed. And mostly salts are white in color, hence why you see white precipitates. So precipitates is a fancy science word that we all need to use from now on. All right? But it means small solids. In this case, we have salt being formed. Afterwards, once the reaction is done, you put it back into the beaker and on the electronic balance, and you would see what is the reading. So what do you notice? What's the reading? It's 11 grams, right? So let's write it down. What is the total mass after the reaction? It is 11 grams. What was it in the beginning? In the beginning of the reaction, it was 11 grams as well. So what does this tell us? In the beginning of the reaction, it was 11 grams. After the reaction, it is still 11 grams. So from the results, was there any change in mass? The answer is no. There is no change. Hence, from this experiment, what we know is the mass of reactants and products is conserved in neutralization. Conserved means it remains the same. So any reaction that occurs in neutralization, if you add any acid and alkali in the beginning, whether it's 50 grams, 20 grams, 10 grams, at the end of the reaction, it will still remain the same. All right? So this is the concept I wanted to introduce to you. We'll talk more about it in the next video. So that's the end of this video. I'll see you in the next one. Bye.